Hello and welcome to all students. This is FY BCom semester second class Mathematical and Statistical Techniques second unit number 2 derivatives and applications. So in this lecture we see some applications of derivative, and in the previous lectures we have studied some functions in economics. So some of these functions are: first function is a demand function. Just we revise all these functions. Demand function, and that function is denoted by capital D is equal to f of p, and demand is a function of p, or sometimes that demand function is denoted by p. Okay, so written as the demand function is given by p is equal to f of x. Okay, next is a supply function. Second function is a supply function where x is number of commodity demanded and p is the price. Okay, now second function is a supply function. And that supply function is denoted by the notation S is equal to some function of price p. Okay, function of price p. Now next function is a total cost function. We call it is third. It is a total cost function. Total cost function. And the total cost function is written as c is equal to f of x, and average. Second is average cost function. It is fourth, average cost function. It is denoted by AC, and it is given by C is C divided by X, average cost function. Next, fifth function is a revenue function, total revenue function. Total revenue, REVENUE, total revenue function. And it is denoted by the equation R is equal to P into D. P is the price of commodity and D is the demand of the commodity. Next, sixth function is average revenue function. AVERAGE, average revenue function. And average revenue function is denoted by the notation AR, and it is defined as PD divided by D, and it is equal to P. So average revenue is always equal to the price of the commodity, or the price of the commodity. Now seventh function is total profit function. Total profit function, and the total profit function is given by the notation is P. It is defined as total revenue minus total cost. Okay, and we recall that if y is equal to f of x, y is a function of x, then the rate of change in y with respect to change in x is denoted by the notation dy by dx, and it is nothing but the derivative of the function f with respect to x. Okay, the rate of change in y with respect to x is nothing but the derivative of function y with respect to x. In the economics, the rate of change is called as marginal. In economics, rate of change is called as marginal. Okay, is called as marginal, means derivative is a marginal, is same as marginal. Okay, so that is very important. Now let us go to the marginal functions in economics. Marginal functions in economics now. Okay, so next point is marginal functions. Marginal functions. So first of all we see the marginal demand. Marginal demand and it is denoted by the notation MD. So as demand function is known to you, demand function is denoted by the notation D is equal to F of P. It is function of P, therefore marginal demand. So as we write here now, as demand function, it is function of P, therefore marginal demand is equal to derivative with respect to P of the demand function. Okay, derivative with respect to P of demand function. Okay, dp. Okay, so this is called as marginal demand. And second is a marginal supply. Marginal supply, SUPPLY. Marginal supply is denoted by MS, and as supply function S is equal to this function of P, therefore marginal supply is nothing but the derivative of S with respect to P, with respect to price P. Okay, with respect to price P. So this is called as a marginal supply. A marginal cost, marginal revenue can be defined accordingly. Let us solve the few examples based on these concepts. So let us go to the next. Third is marginal cost. Marginal cost is denoted by the notation MC, and as cost function C is equal to capital C is equal to this function of the x, function of x, therefore the marginal cost is nothing but derivative of cost function with respect to x. Okay, now fourth is a marginal revenue. Marginal revenue, and it is denoted by MR, and as revenue function is a function of P, therefore marginal revenue is nothing but derivative of revenue with respect to P. Okay, so all these things are now known to us. Now based on this, let us try to solve some examples. Let us try to solve some examples. Example number 1. Example 1. So, or we can say we try to solve some questions now. Okay, so first question is the demand function is given by the demand function is given by capital D is equal to 1 plus 3 times P minus P square. Okay, demand function. Full stop. Find the marginal demand at P is equal to 1. Find the marginal demand MD at P is equal to 1. So let us try to write the answer of this question. Okay, so we have to find the marginal demand at P is equal to 1, but demand function D is given to be 1 plus 3P minus P square demand function, and we know that the marginal demand is equal to, it is derivative of D with respect to P, derivative of D with respect to P, and it is equal to derivative with respect to P of the function D, that D function is 1 plus 3P minus P square. Okay, and it is equal to derivative of this function with respect to P. So we see here it is addition of three functions. First is constant function, and derivative of constant is 0, plus derivative of 3P is 3 is a constant as it is, derivative of P with respect to P is 1, minus derivative of 2P square, P square is 2 into P. So finally it is 3 minus 2P. So it is marginal demand. Now put P is equal to 1 in this marginal demand. Therefore marginal demand is equal to 3 minus 2 into 1, and it is equal to 3 minus 2, and it is equal to 1. So marginal demand is equal to 1. So okay, at marginal demand is equal to 1 at price P is equal to 1. Okay, so this is the answer of this first question. Let us go to the question number 2. In the second question, so let us write the question. The cost of a manufacturing X toys is given by the cost of manufacturing X toys is given by C is equal to x square plus 5x plus 5, where x denotes the number of toys manufactured, where X denotes the number of toys manufactured. Number of toys manufactured, full stop. Find the total cost, average cost and marginal cost when 10 toys are made. What we have to find here, find first is total cost, second is average cost, third is marginal cost, marginal cost when 10 toys are made. When 10 toys are made. Okay, so let us write the answer of this question. Answer. So first of all, what is given, we write what is given to us. We have given a cost function and it is x square plus 5x plus 5. This is our cost function, and what we have to do is first we have to find a total cost at x is equal to 10. So x is number of toys are made. So total cost C is given by C is equal to 10 square plus 5 into 10 plus 5, and it is equal to 100 plus 50 plus 5. So total cost is 155. Okay, so C is 155. Now let us go to find the value of next average cost. Second, we find average cost. Okay, so average cost, it is denoted by the notation AC, and average cost is equal to capital C divided by X, and it is equal to capital C divided by X means okay, so capital C is x square plus 5x plus 5. Okay, and whole divided by x is x, so it is equal to, if I divide by this x to each term in the numerator, we get x plus 5 plus 5 upon x. Okay, and we find the average cost at find average cost at x equal to 10. So average cost is equal to 10 plus 5 plus 5 upon 10, and it is equal to 55 plus 1 half. Okay, so it is equal to 55.5. so this is average cost. Okay, sorry, 50, not it is 55, it must be a 15. Okay, it must be a 15, and okay, 15.5. Okay, so average cost is 15.5. Now let us go to the next. Third is to find out the marginal cost. So marginal cost is denoted by the notation MC, and marginal cost M into C or we can say simply MC. MC is equal to, it is nothing but the derivative of total cost with respect to x, but the total cost is given to be, it is given to be x square plus 5x plus 5, okay, and it is equal to, it is 2 into x plus 5 plus 0. This is marginal cost, and we find marginal cost at x is equal to 10, okay. Therefore marginal cost is equal to 2 times 10 plus 5, and it is equal to 20 plus 5, and it is equal to 25. So this is the value of marginal cost at x is equal to 10, okay, at x is equal to 10. So 25. Now let us go to the next question. Next question is, now let us go to the question number 2, okay, question number 2. So write question. Question number 2 is, the demand function P in terms of quantity demanded D is given by. The demand function, P in terms of quantity demanded, in terms of quantity demanded, D is given by P is equal to 30 plus 12 into D minus 4D square, full stop. Find the total revenue. First that we have to find is total revenue. Secondly we find average revenue, and third we find the marginal revenue. When demand is 4 units. When demand is 4 unit. When demand D is equal to 4, okay. Now let us try to write the answer of this question, okay. Answer. So first of all we see what is given to you. We have given that a demand function, okay. What is given to you? A demand function is given to you, and that function is capital D is equal to, demand function is given by P is equal to 30 plus 12 into D minus 4D square, okay. So this is the demand function, and we have to find the total revenue. So let us go to find one by one. First is total revenue. So total revenue R is given by this formula of P into capital D. Okay, total revenue is given by P is equal to capital D, and it is equal to P function is given to be 30 plus 12 into D minus 4D square into D. Okay, so it is equal to, now multiply by D inside the bracket, it is 30D plus 12D square minus 4D cube. Okay, so this is our total revenue R, but we have to find this total revenue at demand put D is equal to, we have to find this total revenue R at demand is equal to 4 units. Okay, therefore R is equal to 30 into 4 plus 12 into 4 square and minus 4 into into 4 cube. Okay, so it is equal to 30 into 4 is and if I calculate the value of this, if we calculate these three things, we have the answer of 52. Okay, answer with 56, sorry. So total revenue R is equal to 56. You can make the calculation on the calculator. Okay, now let us go to the secondly we have to find the average revenue. Average revenue, and it is denoted by AR. So average revenue is nothing but R divided by total revenue divided by D. Okay, total revenue divided by D. Here it is equal to, but total revenue is P into D divided by D. Okay, and it is equal to, we got it is D. Okay, so D, we got it is D. 1 minute, there is one mistake here, must be a capital D. Here must be a capital D. Okay, so DD will get cancelled and what is left is P. So average revenue is equal to P, and P is nothing but 30 plus 12 into D minus 4 into D square, and it is equal to 30 plus 12 into 4 minus 4 square. Okay, and it is equal to 30 plus 30 plus, or if we calculate all these things, the calculation is of 14. So total calculation we got, it is 14. So average revenue is equal to 14. And now finally what we have to find is the marginal revenue. Marginal revenue MR. Okay, so marginal revenue MR is equal to, it is a derivative of revenue, total revenue with respect to P, derivative of revenue with respect to P. dp dd, sorry, and it is equal to, okay, it is equal to d by d of revenue is 30d plus 12d square minus 4d cube. Okay, and it is equal to, if I take a derivative, we get it is 30 plus 24d minus 12d square, but we have to find this marginal revenue at demand. D is equal to 4 unit. Okay, so marginal revenue is equal to 30 plus 24 into 4 minus 12, 4 square. So use calculator and do this calculation, and what we get is minus 66. Okay, so this is marginal revenue at D is equal to 4. Okay, so this is the end of this lecture, and thank you for paying attention. Thank you very much.